Let's talk about fleet management itself. What is fleet management? Fleet management, it's an art, it's a science, it's an engineering of managing different assets. And these assets could be cars, these assets can be tractors, these assets could be ships, and it can be also like any asset, you name it. Right now, I would say that the whole software industry divided into parts. We have custom solution from different companies like Amazon, like DHL, like UPS, and they have their own systems. These systems, they are focused for their current needs. They are closed. There is not so much data about it. So there are some signs that these systems they have evolved for, let's say, truly reflect the current needs of the operation team. And we have these SaaS platforms, which are dominating the market right now. Some of them are huge, like some automotive get apps. Some of them are like pretty much small. But what I would say that right now, I wouldn't say that we have like a monopoly in the fleet management SaaS business. The market is pretty diverse. There are different companies from all over the world competing for the client. They are competing on a different dimension. Some of them are providing better devices, like OBD devices that can read data from the car computer. Some of them are focused on the dashcams, which is like a new frontier AI telematic. But most of them, they're doing the same. They're doing like the basic tracking. They're doing like house of service compliance. Um, they're trying to provide you with the functionality of predictive maintenance, so you will save on the maintenance of your fleet. And the main two questions are very simple. Where is the money? Why is it important? And what's the fun? So where is the money? Efficiency is a new oil. And when you're talking about the fleet management, the ability to create better roads, the ability to reduce the idling time for a fleet, it actually allows you to save fuel. So these data will be transferred to money directly. And why it's fun, what I love about it, it's actually these fleet management SaaS solutions and fleet management itself, it's a little bit of everything. Yep, can connect to real people with real operation. You are working with real hardware, like piece of metal and plastic. You're also working with a software platform. You're working with system networks. You're working with data analysis. You're working with AI. Everything from everywhere in one place. That's why I would say it's really worth your attention. It's really fun. So before we will deep into this debris of AI, machine learning, and data analysis, let's think about like some important stuff. Fleet management and these sensors, these devices, they're producing a lot of data. And the system is, let's say, mature enough to get this data right and to work with this data. But still, we have such issues like the one I'm showing you on the screen when we have two lawsuits in Texas, where, in a nutshell, what happened? There were different companies, like honestly dozens of them, who were collecting data from the cars, from the mobile phones, from different apps. They were selling this data to aggregator, a large company, and then this aggregator was selling this data to insurance company and some service company. And what came in the end is that one day, specific business, specific person, they saw that their payment for insurance jumped twice. The idea of a lawsuit was that these persons, these businesses, they haven't gave the permission to manage this data this way, which is also like right now we all have a court decision, so it was proved. But during this court, you had an ability to review how these companies are actually were processing this data. So you will have in details explanation which data was taken, assumption have been made for usage of this data, and how actually this company jumped from the raw data from devices to the idea that the specific person should pay twice. And here you will also see, let's say, some common mistakes. Well, first of all this data, I suppose, based on the decision text that I saw and documents, it was normalized in a very straightforward way. All these practices, what we have in EPAM and which we heard about like data governance, about traceability, about explainable AI, they work on very rudimentary like level. So basically, they took all the data from mobile phone, data from the integrated device, data from Bluetooth dongle. They were combining it, and based on this, they made simple regression, and then they classified the customers, like the end users of these applications, giving them score. And I would say that this obsession with scoring, it's our current like the biggest problem in different industries, and it also like shows the little bit maturity of the fleet management itself, like fleet management software itself, right? Because we are using data in this very straightforward way. So in this specific case, companies who shared this data, they faced lawsuits. They lost about 1 million, not a big like fine, frankly speaking. But anyway, these we had a confirmation from the government that it's like bad practice. The question is why? Well, when we're talking about the scoring, when we're talking about the usage of this data, usage of machine learning models to score our customers, we need to look back. It took about 300 years for life insurance companies to like understand how to calculate the right insurance compensation, like insurance premium for the specific person. It took about 60 years for finance sector, for bank, to understand what is the right way to do a bank scoring. Which value can you actually use to increase or to decrease the person to make decision if should you give the credit or not. But and these like areas were really highly regulated. But for some reason in fleet management we don't have this such regulation, and we are like in fleet management can assign the score based on our expectations, yep, and based on our assumptions, based on our models. And that's why engineers and data analysts and machine learning engineers, they need to be precisely sure how are they using these models and what is the data. For example, this is one anecdote. This is one, let's say, simple case which shows what I'm talking about. There was a guy who was actually a member of the roller coaster enthusiast club. So he just loved roller coaster. He was doing it a lot. And also he has an application, he has a mobile phone. He get used to take it with him when he was doing this roller coaster. And one day he got a message that his insurance jumped like 3-5 times. So he was tough enough to request from the insurance company why. And these calls the sequence of events that shows how actually those insurance companies and those engineers manage this data. So, for example, they took one of his ride on the roller coaster, and they make an assumption that he is driving a car in a forest with a speed of like 100 miles per hour with a huge acceleration, and so on and so on. So then I believe the anecdote is how the company that made this model, how they face this issue. They told, guys, we actually we are taking it serious. So starting from this day, we're gonna set volunteers, we're gonna make a new model, and we're gonna train it on the roller coasters, and we're gonna train it on the sky resorts, which leave open the question: how about like flying into the space? How about diving into the ocean? Same again. In this specific case, that's a lack of understanding of what the fleet data is, how to manage manage the context of these geospatial events, and specific immaturity of managing this data and applying it on like in this scoring. And one of the reason why we have this immaturity is actually that the science of fleet management is old. It's like it starts from the earlier seven bridges, like 300 years ago. Yep, but the software which we're using right now, it's pretty new and it's developing very fast. The zoo of devices you can use, the actual hardware you can use in the fleet management, it's like extremely extended. So it's from like you can use your phone. Your phone, it's an ideal TCU, telemetry control unit. It has GPS, it has accelerator, it has connection to internet. Sometimes it has connection to the satellite devices. It has video camera, like you name it. Then if you want to connect your device, for example, to the car via the BLE dongle, you will also be able to transfer the data from the car computer directly to the cloud another way. So you can also have this dongle separately with GSM model and GPS modem. So this specific BLE dongle will be a simple device, very cheap. You can use SAT devices, the devices that are connected not to a cellular network, but to a satellite. You can use cameras, specific dash cameras that some of these dash cameras, they use AI, they use computer vision to recognize specific events like seatbelt and so on. So some of them are pretty straightforward, so they're recording the full trip, and then later operational managers can review it if they need it. Talking about the data we're receiving with these devices, again, these data is very diverse. So literally everything you can get from the car computer, you can, or with extended service of the device, you can transfer to the cloud. That's like RPM, tire pressure, battery charge, engine on, engine off, temperature, everything. And what you need to know, what is important, that right now this connection, the connection, if you are connecting, for example, your device via OBD port, which is like a specific port developed to connect different devices to your car, this connection is bidirectional. So you are not only sending data. You can remotely do some things with your car. You can, if you're using JBus and sometimes OBD, you can control your engine. You can control your lights and so on and so forth. A lot of this function of your car can be controlled. There are these service codes. So this connection is bidirectional, which also like a big question, because we need to think about, as engineers, we need to think about the security compliance. How are we protecting this data? How are we protecting drivers and business from inappropriate behavior of third party? And there are some movements in this area. For example, the specific law has been brought to public last year in the United States. So they officially made some regulation on the car software, like for security reasons. And the thing which I would say we will take it as an example, and we're talking about it a lot, it's a heartbreaking event. Yeah, this heartbreaking event, it's actually information about the sensors that somebody had like heartbreak. What's wrong with all of this? Let's go back to scoring. When we're talking about the scoring, most of the companies, like let's say SaaS fleet management companies, they use scoring, and they're directly telling you that, hey, we use these heartbreaking events which they assume as aggression driven, as an element of our driver behavior score. Now, as an engineer, you would like to ask, okay, so how are we receiving this specific event? There is a specific physical parameters in the device that manage, that actually calculate it. Why do we think that actually this like harsh break even it's like bad? Why we are scoring it as a even that decrease the driving score? There are some articles from some of them are from Google, and they simply made a research that on the specific part of the road there is a big chance of accident. And also in this specific part of the road, there is a lot of, there's a big percent of harsh brake events. So they show this hard correlation between these accidents on this specific road and harsh braking events. And they, based on this, they assuming that some kind of causation, that harsh braking will lead to accident. Honestly, in all these science research articles, there is no such word causation. They only highlight and correlation, that's all. But later, analytics, data analytics engineers in this fleet management says, they presume this causation and they start and use this heartbreaking event, decreasing the score of a driver and like increasing, for example, the compensation for insurance, like the payment for insurance. Now, I would say that this obsession, the scoring and immature analysis of the data, that's a great example here. Because let's say it honestly, there is another event, like you say, brake reaction time, which also telling you that if you see the danger in advance, and if you can hit brake in advance, you are saving a lot of, like you can save someone's life and you can bring less damage. And the question is, can we say that these two events were overlap? We are human, we don't like harsh things. Yep, so just because we name this event, just because we have some kind of correlation, we are punishing some people for like traveling the streets with a big percent of accidents. And sometimes when these people, they're working for business, they don't even choose this road. They assign to walk the specific way. On this way, there is a big percent of accident, and they will be punished for this. That's the example of the immaturity of the market. That's the example when you're treating the data wrong. That's the example we're treating when you're modeling the data without understanding of the context. So talking about the video data, again, that's mostly the question of the security. Like right now around, there is a lot of commercial fleet driving, and they also have this dash cam, and this dash cam is transferring video to the cloud. And you need to be precisely sure that you're actually giving the right permission to the specific person to review this video. Why are we doing it? Why actually like engineers created these dashcams? Because most of them, they use computer vision functionality. They're using machine learning to recognize some events, which I show you. You will see here. Yep, it's distracted driving, lane departure, smoking in the car. But also imagine that right now there are some case of security, vigilant security, when we have the software that will grab the video from a specific car when this car passes a specific crossroad. So some third-party software will have close to 24/7 video guidance of this specific crossroad. Yep, so there is a lot of ways how these fleet management data can actually, I would say, intervene your life. Now let's go to something more like interesting. So let's take in account my story about this hash breaking event. I prefer to think about the fleet management data as a data cake. So I think you get used to it as a data flow. Hey, we receive data here, when they move it here, when we're processing it here, when we have some kind of medallion structure, yara, 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 and it ends with specific data consumer. I prefer to think about it as a data cake because you are producing the cake as a slice of every layer. And that's a very good, good practice in data management and data analysis. When you're not only producing the answer, you're also producing this traceability, explainability, governance, and even sometimes you're producing raw data to prove your your forecast, your KPIs. So thinking about this, I will also make some kind of unconventional division. We will review this data in two steps: data that can be processed on the edge device, data that will be processed in the cloud. Let's move there. So first of all, we need to understand that this device connected to the car, modern device will receive streaming of different types of data, a lot of it. Some of these even has rows, like you have your company different events and you're creating the new event. Like this hash break, it's actually a combination of different events into one new one that is important for business. So it's a constant stream. Then you actually have the internal storage. Imagine if in some case you will lose the connectivity to internet, you actually don't want to lose this part of the streaming. You are collecting it in some storage and in the idea to send it later. Then you need to think, okay, so when this process of sending data, it's one of the most expensive things in fleet management. And take into account that all the fleet management, it's about efficiency, you actually need to think about how to save your client money, customer money for like processing right amount of data when you're not losing actually the insight. Yep. So you can actually send, you can have on your storage all the data from all the sensors, but only say location details, because you understand that there is no changes. Your car is standing still, the engine is off, everything is okay. You don't need to send a bigger package. You can send just simple geolocation and okay, no need to worry. Yep. Or in some cases, you want to have near real-time streaming. Well, managing what data you are sending to the cloud and what data you're actually processing on the edge device, that's how you can manage your profitability, and that's how we can manage cost of solution. That's basically very important. Then let's say in the cloud, we have this architecture, and I presume a lot of you know this medallion architecture when you have broad cylinders and gold layers, and a lot of companies, they actually made this architecture before they was even introduced to this data architecture approach. So you need to have some kind of landing zone when you have raw data, when you have, we have it, for example, for a couple of years to provide the opportunity for time traveling, to provide some kind of backup. Then you have a specific layer when you can normalize and adjust data. For example, when we're talking about the fleet management, think about all the data sets that you can add to your geospatial data. So in the beginning, you have sensors data from the car, and you have geolocation, longitude, latitude. And then there is simple that you can add not only geo point, you can get address. So it's not only like two numbers, it's the Becky Street 303. Then you can add specific data set about the traffic. So you will understand that in this specific place, the traffic is huge. Then you can add the data set about the weather. So, for example, your fleet manager, when he sees that the fuel consumption jump up, he will understand, okay, we are spending more fuel not because we are like managing inefficiently. It's just very cold, and the cold car consume more fuel. So you will flatten the curve. So the more data set you can add, the more insight you will have from your data. Then you actually has some business related data, and again, you name it, different businesses, they consume this data in a different way. Some security firm, they need like we need to have exact route of the car, and they need to have some of like exact moment when the car was turning off, and so on and so on. Some like businesses, they only want to see daily consumption, hourly consumption, and so on and so on. They just want to see the KPIs. And on the top of it, on the top of all these data, you will have this AI machine learning layer. And what I need to emphasize is that it's extremely important in fleet management software, in the fleet management. Why? Because fleet management is about efficiency and operation. And operations, the meaning of operations, it's a constant changes and constant making decisions. And any tool that will allow you to make right decisions in a specific moment immediately will convert this tool into money. Which means if you can not just provide the specific dashboard, but explain what should you do based on this dashboard. Like, hey, it looks like in 2 hours you will see a reduction on your ODT, like delivery time. You need to send more cars. Hey, it looks like your fuel consumption for this specific month is higher than the consumption of the same company with the same cars during the same period. You need to take a look what are you doing wrong. And you need to please review these 2 cars in these 2 segments. So these specific advices that can be right now done with GenAI, simply transferring the data into the knowledge. They're extremely important, and that's, like I would say, the next frontier. There are systems that do it right now. Most of them, again, they're pretty immature. And again, let's remember these harsh break events, because you need to pay a lot of attention to how are you analyzing, how you're actually conceptualizing the data. Now, let me share with you actually my own experience. A little history. I managed. I was working with team that works with language models. We use models with transform architecture in a legal practice. So, and then like 4 years ago, I joined a company, and that was like a fleet management company. So my first task was to work with a big agricultural company and this company wanted to operate their tractor fleet efficiently. Now imagine this. Look at this guy. He's standing on the hill. He looks at the tractor above, and imagine it's you. Even if you are not a farmer, just looking at the tractor, you will understand what is it doing. You will understand, okay, it looks like it makes this zigzags movement constantly, or it looks like it's just standing still, or it's like directly traveling from one field to another, and you just simply understand it without getting any data like from the tractor sensors. You will understand because you see the tractor's trajectory. Yep. Where the problem came? The problem came that different types of engineers were trying to resolve this problem, how to distinguish with these types of mode in a different way. So, for example, some of these, let's say hypothetical example, some Japan company, they made tractors. They also made these implements for plowing, seeding, so on. So there is like a Japanese engineer, and they think, okay, so I need to actually to distinguish time that tractor spent plowing and traveling to the field. How can I do it? Well, the most simple way to do it is just to create the, let's say, smart plow. The plow that will actually talk to tractor and tell it, hey, right now I'm connected, we are plowing right now. Or like a specific seeder that will say, okay, right now we are seeding with this intensity. Where the problem came. Imagine this smart Japanese tractor arrives to Mexico, and it meets Mexican plow, and Mexican plow, it's just a piece of metal. It's not that smart. And if the specific driver want to connect this plow, if he saw this moving part, like the arm that can signal that actually some implement is connected, he can use a hammer to fixate this arm in the fixed position, connect this plow, and then make plowing. So in half a year, your smart Japanese tractors will be not so smart, but they're still sending the data. But right now, this data is incorrect. Add here that there is legacy fleets can have different types of tractors. Some of them are not smart, some of them do not have these installed devices, and you will understand that actually you need a better solution. Now, my first, and again, I will share with you like some history about my mistakes. There is no something like commercial secrets here. So was to implement transformer. I came from the natural language processing industry, so I think, okay, so we will use transformer here. Transformer can do everything, and it sucks. Then after 1 week of spending company time and company money, I started to review the articles, and I saw actually there is a lot of articles that shows you how to use RNN and LTSM system, and in the end, in the different iteration of experimentation, we found the article that explained how to use GAN plus BLTSM, long time memory network, artificial network for this case, and it works perfectly. And it starts to provide the correct data. Then later, engineers smarter they are, they like commercialized and productized this solution. But again, what is here? Here is the solution. You are simply doing the same as that's the machine learning, that's artificial intelligence. You are simply learning your algorithm to recognize same patterns that you can recognize with your eyes. Now, where is the money? Where is the fun here? The fun here is right in my case, all these calculations, they were made on the in the cloud. But why can't we just do the same on the edge device? Why can't we just send these neural network on the same device? The answer is at this time the industry is not mature enough to accept the fact that we need to provide devices that can run these networks, and also these networks, they are not optimized for this type of very small device with very small memory, with let's say so they're not so powerful. But there is something that I want to share with you. There is one company that I'm like guys from MIT, and I'm observing their work from 2022. They created the new architecture specifically for edge devices. These architecture reintroduce time for time series data as an entity. So in normal, all this data we are talking before, all this data, sensors data, geolocation data, it's a time series data, which means you are receiving the point and you are receiving the time connected to this point, and you are receiving sensor data connected to this point in time. So you have like a sequence of events. But in 99% of neural networks, this time it's an index. Previously in the industry, there was like a type of architecture, ODE networks, and they were like completely, they were very slow because they need to resolve these differential equation each time they made the, they want to make the predicted. It was like in the activation layer. So what these guys in MIT did, they found the resolution. They found how to resolve this ODE problem in the right way with a good approximation, so that these networks that has like time as an entity, and they have time as an entity in the activation layer, they can basically use they were called liquid network, and they created for time series data. They created to be small. For example, one of the founder of the company, Roman Hassani, he on his TED talk, he showed how he can manage the car with artificial network, but only have 19 nodes. 19. So why is, again, where is the fun, where is the money? First of all, the fun is that you can actually create the smart devices with agentic behavior. Imagine that you are not only when you install this device, it can actually think what data should it send right now. It can recognize different pattern on the edge device, like this tractor. All the calculation for this tractor efficiency can be done on the device, and it can only send the ready KPIs to the cloud. It can actually interact with the driver to understand is it okay for some security reason. So these small efficient networks can be used in the edge devices, and they can be used to provide agentic layer to this fleet solution on the edge device. That's, I would say, the next frontier, and also what I would like to mention as we actually move in this direction. So I will be honest with you. You will see these like 4 devices. I only had like a honor to work with one of these company. It's Munich. This is French company. Good engineering, good understanding. So right now, different companies, they are trying to introduce neural network on their devices. Like they are creating operating system, and on this operating system, like they're trying to make this neural network as small, as efficient as they could. So that's the correct movement of the industry. And remember, why are they doing it? They're doing it, first of all, to provide the more complex behavior recognition on the device, to analyze more data on the device and save money on sending only the right data, on the pre-calculated data, only the right amount to the cloud, to the customer. Also, I would say it openly, the current it will help to reduce this problem with all the scoring algorithm, because you will be able to run specific complex models directly on the streaming data, and not you won't use this like simple, sometimes stupid regression on the data collected from a different source in the cloud without understanding what does it actually mean. So that's how we can make this like industry smarter. We can make more calculation on the edge device, and it also will be cheaper. Okay, so I think right now it's already time for questions.
Yeah, thank you very much, Alex, for interesting presentation. Yeah, we have several questions. Uh, yeah. So yeah, first question, a bit direct. Is this area growing fast or still niche? Would you recommend going into it?
So this area simply connected to the commercial fleet itself. Can we say that commercial fleets are growing? I wouldn't say that we see the exponential growth of commercial fleet. Can we say that we finished the adoption of a fleet management software in this commercial fleet? I wouldn't say so. So it's a limited area, but there is still some opportunities because these best practices, they have not been adopted by all the companies. So if you would I recommend to go there only if you like this kind of fun I have described. But you will be able to work with literally everything, starting from hardware and finishing the developing the machine learning models on the top of the data from them.
Mm-hmm. Okay, thank you. We have yeah, one more question. Um, if someone wants to start learning IoT plus ML today, what would they begin? Maybe they can create already something in like own hardware, or maybe you know some sets.
So at the end of this presentation, I have a link to a data set with actually like IoT
Mhm.
data. And there are a couple of them ready in GitHub. And also there is like an amazing Chinese company and amazing Chinese research like who shared a lot of data, and you will have this raw data, and also they have their own models. Everything's open source. So yeah, you can just simply go there.
Mhm. Yeah, we have one more question. Probably it was a reaction to those anecdote. Is it safe at all? Like, is it like proper at all to use data from phone comparing to car-mounted sensors? Yeah, because maybe
Okay,
phone data, yeah, it's not like proper source of data.
is it safe?
Is it proper? Something
Proper.
like that.
I would say it very clearly. It's not safe to connect any device to your car if you don't understand how does it work, and if you don't have complete trust to the like provider of this service. As I told you, these devices, they are right now work in both direction.
Mhm.
So by connecting your phone, you're actually connecting some third party to your car. And also it goes another way. If you have a GPS device, some of this device can be connected to your phone directly as well. You are given the access to your phone data to the guy who is managing this device. So is it safe? No, it's not safe.
Yeah, but for example, yeah, you gave this example that like person was like in the park, yeah, on this yeah, on having fun, but somebody tracked his phone. So
Yeah,
I mean that so like comparing to the car with this like super sensors, probably calibrated sensors, and comparing to the phone that is
yeah.
like much smaller and like with a lot of noise.
Yeah, well, I would say honestly, again, if you're talking about a specific phone, a specific application, the using your mobile phone as a TCU, as a telemetry control
Mm-hmm,
unit, it's the entrance to the market. Literally
mm-hmm,
everyone did it. Like it's very simple. It's very cheap. Sometimes people they are not so focused on the safety. So yeah, that's pretty normal. A lot of companies, a lot of SaaS companies, they have this ability when you can connect your phone as a TCA unit and use it in your car, or if you have a small fleet of 10 of 10 cars, you can just simply ask your drivers to install this application and use it during the walk, because you don't want to have this vendor log, you don't want to buy the specific device, you don't want to buy specific SaaS. There are some even free solutions on the market. So that's the entry to the industry. Still, is it safe? No, it's not safe, but it's a trade-off. When you're not literally paying anything, but you could possibly have security issues.
Mm-hmm. Yeah, understand. One more question, probably. Yeah, also was thinking about it. What was the coolest real-world use case you saw with fleet data?
So
Yeah, maybe for me it's hard to imagine. Yeah, maybe you can just say what's really, where is it really used?
the coolest, that's a great word, I would say. Like there are smart way to use this data, and there are coolest way to use this data. So what I like to think about is there is like a movement again in fleet management and like city management, when you have all connected network. When you have fleet management data connected to the city management data, when you have semaphores working based on where the cars are, when you have like different, it's like a bidirectional. So I think this like unified vision, when you see all the moving parts as it's something holistic, that's the coolest, I think. And as I understand, that was like it was all implemented in some Japan city, because they were trying to sell it in a different cities, I believe also specifically in Mexico.
Mm-hmm. And yeah, if you mentioned about this dash cameras that send data to clouds. So, for example, can such like face recognition tasks relate to fleet data? So, is it same
Yeah,
or not?
we some like we had an interesting request. Then some company requested to install dash cams, and these dash cam will look, and it will make face recognition of the people walking on the street. So that's, let's say, extended security for the dash cam. So it's like a
Mm-hmm.
it was not police. It's just like was some kind of like neighborhood bus, and they were
Mm-hmm.
thinking about to install it to track specific person in the neighborhood. This project haven't progressed due to a different reason, but again, it's just like an online camera, and you have these computer vision models. All the computer vision models that you can imagine, they can be run on this device with its data. Face recognition, like smoking and lane departure, and so there actually was like a project where those dashcams were had models that was trained to recognize not the face but the specific illegal activity. Like the bus is moving on the street and it saw some people fighting, and it like sent the data to the local. Yeah, this is a little bit far from fleet management, but yes, when like, you need to understand that this video telematics, it's a delicate industry.
Mm-hmm. Okay, thank you. One more question from the chat. Could you please confirm whether any of these architecture models can help enhance an already existing solution toward predictive maintenance? Yeah, not sure if it's clear.
I honestly don't know. I can only imagine that yes, but predictive maintenance, it's a, let's say, I wouldn't say that this task requires these new architecture. Let's say I don't think that's where I don't my personal opinion is not correct way to use it. Predictive maintenance, it's a pretty simple. Sometimes it's not even machine learning, it's statistical algorithm, and it's not really time series data. Most of these data you have from sensors can help here, but 99% is done with you just creating this schedule. Okay, so this specific car should be like maintained after 1,000 kilometers. This specific tire, you also have like in fleet management, tire management by way. This specific tire with these specific numbers after specific amount of kilometers should be replaced. So these kind of the things, it's 99% of a predictive maintenance in the fleet management itself. There are some, let's say, more advanced scenarios, but they are not so advanced. So that you need to use liquid, as I understand them, you should use liquid architecture.
Okay. Yeah, looks like we're out of questions. Okay. Yeah. Thank you very much, Aleksandr, for interesting
Thank you.
presentation and like real scenarios, real cases. Okay, thank you very much, everyone, for joining us today. Yeah, if you like this talk or maybe you don't like, yeah, you can rate it on the talk page and give Alex a badge. Thank you, badge. So your feedback is very valuable for us. Also, on this talk page, you will be able to find the recording and presentation file. So thank you very much, Alex, for your presentation. Yeah.
Thank you for inviting me. Thank you guys for joining. Bye.
Yeah, thank you.